Imagine 62 meters of black water pressing down on you from every direction. No sun, no horizon, no sound except the deep, rhythmic groan of steel under pressure and the hiss of your own recycled breath. The year is 1965, and somewhere on the floor of the Pacific Ocean, off the coast of La Jolla, California, a cylinder of welded metal the size of a school bus is home to a group of men who have chosen voluntarily to live like fish. They call themselves aquanauts. They are running out of a critical tool, a wrench, a specific wrench. And the only way to get it down to them without risking a man's life to decompression sickness, a slow, agonizing death that divers called the bends, is to send something that doesn't need to decompress, something that doesn't breathe pressurized helium, something that slips through black water like it was born there. From somewhere above, far up in the gray-green shallows, a sleek gray shape begins to descend. It carries a pouch strapped to its body. It is moving fast, impossibly fast, navigating the darkness not with eyes but with sound, with a biological sonar that no machine in 1965 could rival. It taps the hull of the habitat with its rostrum just once, like a knock on a door. The hatch opens. A human hand reaches out and takes the package. The creature pauses, hovering in the cold dark, regarding the hand with one ancient, intelligent eye. And then it is gone, spiraling back up toward a sky it will reach in seconds, while the men below would need hours. His name was Tuffy, and what he did that summer changed the history of naval warfare, marine science, and the way human beings think about the other minds sharing this planet with them. To understand how a bottlenose dolphin ended up as an underwater courier for the United States Navy, you have to understand the particular madness of the 1960s space race and its lesser-known twin, the undersea race. While NASA was pointing rockets at the moon, a quiet revolution was happening in the opposite direction. Men like Jacques Cousteau and the American Navy were asking a question that sounds almost absurd today, but was deadly serious then. What if human beings could live and work on the bottom of the ocean, not visit it, not dive to it and return? Live there. The rationale was strategic. The Cold War ocean floor was a battlefield of submarine cables, early warning systems, and Soviet submarines prowling the deep. The nation that could place working men on the seabed for days or weeks at a time would have an intelligence and military advantage that was incalculable. The problem was biology. The human body was not designed for ambient pressure saturation, diving. When you descend to depth, nitrogen dissolves into your blood and tissues under pressure. If you ascend too quickly, those dissolved gases form bubbles inside your veins, your joints, your spinal cord, your brain. Divers had been dying of it for a century. The solution the Navy found was elegant and brutal at the same time. Don't ascend at all. Build a habitat on the bottom. Let the divers live at depth for weeks, keep their bodies fully saturated with the pressure gases, and then bring them up only once, very slowly, at the end of the mission. It was called saturation diving, and the program was called SeaLab. SeaLab I had been a proof of concept, a modest success in 1964. SeaLab II was the real experiment. 10 men living in a pressurized cylinder at 62 meters depth for 30 days, cycling through in teams, doing real scientific and military work. And it needed a support system, a logistics chain, a way to move small objects, tools, medicine, mail, instruments, between the surface and the habitat without requiring a human diver to make that dangerous two-way transit every single time. That was where Tuffy came in. But the story of how Tuffy got there begins not in the ocean, but in a tank in Point Mugu, California, where a young bottlenose dolphin had been showing his trainers something that no one had fully expected. He was not just learning tricks, he was solving problems. The U.S. Navy's interest in marine mammals was not, even in 1965, a new thing. Research into dolphin cognition and echolocation had been ongoing since the late 1950s, driven in part by the work of neurologist John Lilly, who had published startling claims about dolphin intelligence and even suggested controversially that they possessed a language. The Navy was more interested in practical applications than philosophical ones. Their sonar systems were good, but not good enough. Soviet submarines were getting quieter. The ocean is a complex acoustic environment, full of thermal layers and geological features that deflect and absorb sound waves. Bottlenose dolphins, it turned out, had been solving that problem for millions of years. Their biological sonar, echolocation, could identify objects in total darkness, discriminate between materials, detect shapes at range, and do all of this in the kind of complex, turbid, current-ridden coastal water that defeated man-made sonar systems. The dolphins, being trained at Point Mugu, were not being taught to do anything unnatural. They were being given human tasks to accomplish with their own native, extraordinary capabilities. Tuffy was selected from this pool of trained animals specifically for the SeaLab II mission. He was a male tertiope, fully adult, already familiar with open water work, which was itself a significant achievement since many Navy dolphin experiments were confined to enclosed bays or lagoons. He had shown, during training, an unusual degree of what the handlers called initiative. When a task was interrupted or went wrong, Tuffy did not simply stop and wait for a new signal. He improvised. He found a way to complete the objective by another route. The handlers noted this in their reports with a mixture of professional interest and something that, reading those documents today, sounds very much like awe. He was also, by all accounts, exceptionally social. He liked people, not in the performed, treat-motivated way of an animal going through conditioned motions, but in the way of a creature that appeared to find human company genuinely interesting. That quality would matter enormously in the months ahead, because the man he was about to meet was one of the most remarkable human beings of the 20th century, and their partnership would define both of their legacies. Scott Carpenter was already a legend when he descended into the SeaLab II habitat in the summer of 1965. He had orbited the Earth 3 times in 1962 aboard Aurora 7, the second American to do so, following John Glenn by 3 months. His flight had been tense, dramatic, nearly catastrophic. His capsule splashed down 250 miles off target after a malfunction, and for 40 minutes, the world believed he might be dead. He was found alive, floating in the Pacific, grinning. After that mission, Carpenter had been grounded due to a motorcycle accident that injured his arm. While recovering, he had turned his attention not upward, but downward, joining the Navy's Man in the Sea program. He trained as an aquanaut with the same focused intensity he had brought to the astronaut program. By the time SeaLab II was ready, Carpenter was its most prominent inhabitant, scheduled to spend a record 30 days on the bottom, logging more time in the underwater habitat than any other individual on the mission. He would be, in the language of the program, the aquanaut who spent the most time with Tuffy. What developed between them was not, by any clinical measure, what it appeared to be. Carpenter was a scientist. He understood operant conditioning, acoustic signaling, positive reinforcement. He knew that what Tuffy responded to was a specific patterned sound, a recall tone transmitted through a transducer mounted on the hull of the habitat. He knew the dolphin's behavior was trained, practiced, refined over months of repetition. He knew all of this. And yet, sitting inside that steel cylinder, 62 meters below the surface of the Pacific, watching through the thick acrylic porthole as a gray shape materialized out of the absolute darkness, moving with a speed and grace and apparent purpose that no machine in the world could match, Scott Carpenter wrote in his log that it felt like receiving a visit from another intelligence. Not a trick, not a conditioned response, a visit. Seeing Tuffy appear outside the porthole in the cold, black dark of the Pacific, he wrote, was like seeing a guardian angel with flippers. That sentence has been quoted many times in the years since. It is worth pausing on what it actually means. Carpenter had been to space. He had looked down at the curvature of the Earth from orbit. He had floated weightless above the atmosphere. And the thing that made him reach for the language of the miraculous was a dolphin appearing out of the dark carrying a wrench. Here is what Tuffy actually did during the SeaLab II mission, described plainly, without embellishment because the plain facts are extraordinary enough. The habitat had been placed on the seafloor in August of 1965, roughly a mile off the coast of La Jolla, at a depth of 62 meters. At this depth, the water temperature hovered just above freezing. Visibility was measured in feet, not meters. The Pacific off San Diego is not the crystalline Caribbean. It is cold, turbid, rich with plankton, perpetually dim even in the shallowest layers. At 62 meters in the middle of the day, it was effectively night. On the surface, a support ship maintained the logistics chain for the mission. Tuffy was stationed aboard this ship, or rather, he ranged freely around it in the open ocean, something that was itself considered remarkable, since open water work with trained dolphins always carried the risk that the animal would simply leave. Tuffy did not leave. When the aquanauts below needed something, a tool from the surface team, a packet of mail from home, a small medical supply, the service team would load the item into a canister attached to a harness designed specifically for Tuffy's body. The harness was lightweight, hydrodynamic, fitted with a quick-release buckle that the aquanauts could operate through the habitat's diver lock. Tuffy would be given the acoustic signal, the specific pattern of clicks that meant go down, and he would go. 62 meters in the dark, moving through water that a human diver would need decompression equipment to survive ascending from, Tuffy descended at a speed that made his passage almost invisible on the surface cameras. He would locate the habitat, not by sight in the darkness, but by the acoustic signature of the machinery inside it, the hum of the air recycling systems, the particular echo of steel cylinder in water, and he would bring the package to the diver lock. The aquanauts would open the hatch, retrieve the canister, unclip it, and Tuffy would ascend. Total time for a delivery, under 4 minutes, portal to portal. A human diver making the same trip would require several hours of staged decompression stops on the ascent alone, during which they were vulnerable to current, to cold, to everything the ocean could throw at a stationary body hanging on a line in the dark. Tuffy felt none of this. Dolphins do not suffer decompression sickness. Their physiology handles rapid pressure, changes through adaptations millions of years in the making, collapsible lungs, blood that stores oxygen differently from ours, a diving reflex that slows the heart and shunts circulation away from non-essential organs. He was, for this purpose, physically perfect. The Navy ran the delivery protocol dozens of times during the 30-day mission. Tuffy's success rate was essentially 100%. There were no lost packages. There were no failed deliveries. There was one incident that became, in the records of the mission, the moment that elevated Tuffy from logistical asset to something harder to categorize. During a routine external maintenance dive, one of the aquanauts became disoriented in the darkness outside the habitat. This was not trivial. Disorientation at depth, in dark water, with limited air supply, kills people. The diver activated his distress signal, but in the turbid water, the other aquanauts inside the habitat could not locate him visually or acoustically with any precision. Tuffy was in the water. He heard, or more precisely, echolocated, the diver's position. He found him in the dark, and he did something he had not been specifically trained to do for this scenario. He brought the diver a guide rope, a line attached to the habitat that the disoriented man could follow hand over hand back to the airlock. The diver survived. The incident was logged, analyzed, and filed. The Navy researchers who reviewed the footage and the acoustic telemetry data spent considerable time trying to establish exactly what cognitive process had produced this behavior. Had Tuffy generalized from his package delivery training, the same action, different payload, applied to a new situation? Had he responded to distress signals in the human's movement patterns the way a dolphin might respond to a struggling member of its own pod? The honest answer, then as now, is that no one fully knows. What is known is that the behavior was not scripted. It was not in the training protocol. Tuffy saw or heard a problem, and he solved it. If you are not moved by that, I am not sure what would move you. Drop a comment below if you think animals are capable of true decision-making, because what happened next in this story will challenge everything you thought you knew about the line between instinct and intelligence. The SeaLab II mission ended in the late autumn of 1965. The aquanauts were brought up slowly, carefully, over many hours of decompression, their bodies readjusting to surface pressure after weeks of saturation. Scott Carpenter, who had spent the full 30 days on the bottom, set a record that stood for years. The mission was declared a scientific and operational success. The data gathered on human physiology, on the engineering of saturation diving systems, on the logistics of deep-sea habitation, filled volumes of classified and unclassified reports. And buried in those reports, in the sections that dealt not with steel and pressure gauges, but with biology and behavior, were the files on Tuffy. The Navy's assessment was clear and, by the bureaucratic standards of military technical reporting, almost lyrical. The bottlenose dolphin designated Tuffy had performed all assigned tasks with a reliability that exceeded engineering expectations, had demonstrated adaptive problem-solving behavior in an unscripted emergency scenario, and had proven the feasibility of integrating trained cetaceans into open ocean saturation diving support operations. That last phrase, integrating trained cetaceans into open ocean saturation diving support operations, was the bureaucratic birth certificate of what would become the U.S. Navy Marine Mammal Program, one of the most classified and most studied programs in the history of military animal use. The program expanded rapidly in the years following SeaLab II. Dolphins were trained for mine detection, for swimmer interdiction, identifying unauthorized divers near naval installations, for object recovery from the seafloor, for marking the locations of underwater ordnance. The same biological toolkit that Tuffy had deployed in the cold waters off La Jolla, the sonar, the speed, the pressure tolerance, the trainability, was refined and applied across dozens of operational scenarios. By the time the Vietnam War was in full swing, Navy Dolphins were deployed in Vietnamese harbors, protecting ships from enemy combat divers. The program was secret for decades. Much of what it accomplished remains classified today. But the thread that runs through all of it, the founding demonstration, the proof of concept that made everything else possible, traces back to one summer off the California coast, and a bottlenose dolphin knocking on the porthole of an underwater habitat with a wrench strapped to his back. There are people in the naval research community who will tell you, privately, that Tuffy was not only the first Navy dolphin to operate in open ocean at depth, he was also, in their estimation, the most naturally gifted. The handlers who worked with him described a quality that is difficult to quantify but impossible to ignore in the records. He was engaged. Not just compliant, not just conditioned. Engaged. He wanted to work. He came to the surface ship in the mornings with the energy of a creature that had an agenda. He was visibly, behaviorally frustrated on days when the weather prevented diving operations and he could not complete his runs. Whether that constitutes something we should call purpose or motivation or merely a well-shaped, conditioned response is a question that marine biologists, cognitive scientists, and philosophers of mind continue to debate. But the aquanauts who were there, the men who watched him appear out of the dark 62 meters below sea level and hand them their mail, they had already made up their minds. They would not have used the word tool to describe him. They used the word colleague. Scott Carpenter left the aquanaut program after SeaLab II. His arm injury had worsened, and the Navy eventually retired him from diving operations. He went on to a long career as a science communicator, an advocate for ocean exploration, and an extraordinary example of a human being who had managed, improbably, to be both an astronaut and an aquanaut, to have experienced both the absolute vacuum of space and the crushing pressure of the deep sea. He spoke about Tuffy often. In interviews through the 1970s and 80s, the dolphin was a constant reference point, a touchstone. Carpenter had a particular way of describing what the experience of working with Tuffy had meant to him, and it went something like this. When you are in space, you are aware of the smallness of the Earth, the fragility of the pale blue dot, the loneliness of the human species in a vast and indifferent cosmos. It is humbling, but it is also isolating when you are on the floor of the ocean in the dark and a dolphin comes to find you. Not because a machine sent it, not because a button was pressed on the surface, but because it heard you struggling and came. You feel the opposite of alone. You feel, Carpenter said, like a member of a community far larger than your own species. That feeling, he believed, was important. Maybe the most important thing he had learned in a career full of extraordinary experiences. The men who went to space in the 1960s came back changed in ways that were difficult to articulate. More environmentally aware, more spiritually oriented, more likely to describe the Earth as something precious and fragile. The experience has a name now, the overview effect. Carpenter was the only person who went to space and then, instead of looking back up, looked down, into the ocean, into the dark. And what he found there was not a hostile void, but a world teeming with intelligence, with social complexity, with what he could only describe as personality. Tuffy gave him that. A dolphin with a delivery pouch and a knock on the porthole gave one of America's first astronauts his second great revelation about the nature of life on Earth. What happened to Tuffy after SeaLab II is not fully documented in the public record. The U.S. Navy Marine Mammal Program, which his performance helped create, kept the identities and operational histories of its animals largely classified until the program was partially declassified in the 1990s. What is known is that Tuffy continued to work with the Navy's Cetacean Research Unit for several years after the SeaLab mission. He was, by all available accounts, healthy, active, and continued to be used as a training exemplar. The animal whose behavioral records new trainers studied as a baseline for what high-level performance looked like. He lived, as bottlenose dolphins in Navy care lived in that era, under conditions that were considerably better than the commercial aquarium industry, but still a far cry from the open Pacific he had navigated so effortlessly in the summer of '65. The ethics of the Navy Marine Mammal Program have been contested for decades. Animal rights organizations have argued with some force that training intelligent, socially complex animals for military operations and keeping them in captivity to do so constitutes a form of exploitation that no operational benefit can fully justify. The Navy has argued with equal force that the animals in the program are well cared for, that their training is positive reinforcement-based, that they are not exposed to combat situations directly, and that the capabilities they provide save human lives. Both of these things can be true at the same time, and sitting with the tension between them is part of what it means to take the program seriously. Tuffy did not choose to be a Navy Dolphin. He did not sign a contract or raise a flipper for service. He was born in the Pacific Ocean, captured or bred in captivity, and shaped by human hands for human purposes. And yet by every behavioral indicator available to the scientists who studied him, he was not unhappy in that work. He was stimulated by it. He was, in the language of animal welfare science, enriched. Whether that is enough, whether the enrichment of captivity and purposeful work offsets the loss of the open ocean, the pod, the migration, the millennia of evolved social structure, is a question that does not have a clean answer. It is, perhaps, the question. The one that Tuffy's story forces us to sit with long after the mission is over, and the habitat has been pulled up from the seafloor, and the aquanauts have gone back to their families. If you have a thought on this, if you believe the Navy's use of dolphins is a debt that can never be repaid, or if you think that partnership between species, even asymmetric partnership, has a value that transcends the terms on which it was formed, leave it in the comments. I read every single one of them. Because this story, like all the stories on this channel, is not finished when the script ends. It lives in the conversation that follows. The Navy Marine Mammal Program is still active today. Based in San Diego, it trains bottlenose dolphins and California sea lions for a range of missions that the Navy describes as mine hunting, swimmer defense, and object recovery. The dolphins currently in the program are the descendants, behaviorally, if not always biologically, of Tuffy's generation. The techniques refined on the SeaLab II mission, the open water recall protocols, the harness delivery systems, the acoustic signaling methods developed by Scott Carpenter and his team 62 meters below the Pacific, are the foundation on which the modern program is built. When Navy Dolphins were deployed to the Persian Gulf in the 1980s and 90s, protecting American ships from Iranian combat swimmers and hunting for mines in the shallow coastal waters, they were doing a version of what Tuffy did. When dolphins were used in Bahrain following the Iraq War to sweep harbors before the first humanitarian supply, ships entered. They were following a protocol whose origins trace to 1965 off the coast of La Jolla, in the summer when an astronaut became an aquanaut and a dolphin became a sailor. The program has survived decades of controversy, congressional scrutiny, budget cuts, and the perpetual awkwardness of being a military operation that uses animals many people consider to be among the most cognitively sophisticated, non-human creatures on Earth. It has survived because it works, because no machine, not in 1965, not today, can fully replicate what a bottlenose dolphin can do in turbid, shallow water with its biological sonar at full resolution. The Navy has spent hundreds of millions of dollars trying to build mechanical alternatives. Autonomous underwater vehicles, advanced sonar arrays, machine learning mine detection systems. They are getting better every year. But ask any Navy handler, any marine mammal trainer, any researcher who has spent time on the water with these animals, and they will tell you the same thing. There is still a gap between what the machines can do and what the dolphins can do. A gap that closes slowly, year by year, as the technology advances. But that has not closed yet. Tuffy defined the size of that gap in 1965. He showed the Navy exactly what they were trying to build by being it, in a way that left no room for ambiguity. You want to know what the ideal underwater reconnaissance and logistics asset looks like? It looks like a bottlenose dolphin appearing out of the dark at 62 meters, carrying your tools, finding your lost diver, and then vanishing back into the black water like it was nothing. Like it was just Tuesday. Like it was just what you do when someone needs help. There is a particular kind of humility that comes from studying the lives of animals in service. Not sentimentality. Sentimentality is easy and ultimately disrespectful because it reduces the animal to a projection of human emotion rather than taking it seriously on its own terms. Humility. The recognition that the capabilities we have spent our entire history congratulating ourselves for, navigation, communication, problem-solving, social cooperation, are not uniquely ours. They are not inventions. They are inheritances, variations on themes that evolution has been writing and rewriting for hundreds of millions of years, in bodies very different from ours, in environments we can barely survive. Tuffy had a sonar system that the most advanced military technology of his era could not replicate. He had a pressure tolerance that made human physiology look fragile. He had a social intelligence that allowed him to read a distressed diver's movement patterns in total darkness and produce a behavior, the guide rope, that no one had specifically trained him to produce. And he did all of this with what appeared to be genuine engagement, genuine interest, genuine willingness. Not because he had been told the stakes, not because he understood Cold War geopolitics or the strategic importance of undersea habitation, but because he was, as his handler said, a worker, a problem solver, a colleague. Scott Carpenter, the man who had seen the Earth from orbit and from the bottom of the sea, said that his time with Tuffy had done something that neither space nor the deep ocean had done alone. It had made him feel connected. Not to the grandeur of the universe or the fragility of the planet, though both of those things are real and both of those feelings are legitimate. Connected to life itself, to the staggering, improbable fact that this small, wet rock circling an ordinary star is so extravagantly, recklessly full of minds, that out there in the cold dark of the Pacific, 62 meters down, there is a creature that will come to find you if you are lost, that will knock on your door in the dark, that will bring what you need and ask for nothing in return except perhaps the brief warmth of a human hand reaching through a hatch to take what it has carried. If there is a lesson in Tuffy's story, and there always is, that is why we tell these stories. It is not about military applications or marine biology or the ethics of working animals. though all of those conversations matter and deserve to be had. The lesson is this: the ocean is not empty, the dark is not silent, and we have never been as alone as we thought. Subscribe to this channel if you want to keep hearing the stories that history almost forgot. Stories of animals and humans, of courage and intelligence, of the partnerships that changed wars and changed the world. They are all around us, waiting to be told. Tuffy waited 60 years for someone to knock on his door. Consider this that knock